Hey everybody, so today we're going to be talking about the continuation of the transformations but within a logs standpoint. Okay, so let's go ahead and jump on into it. We're going to talk about the horizontal translation first as always, so let me go ahead and set that up. Alrighty everybody, so first thing we're going to make sure we're comfortable with is the original function, or also known as the parent function, log of x, so basically nothing done to it. What we have to know is where that particular point is, because originally when we talked about with exponential functions, the point that was very important to us was this one right here at 0, 1. But since the log is actually the inverse of an exponential function, it's actually going to start at 1, 0. And what's also interesting is we said that for an exponential, the asymptote was along the x-axis. But now for a logarithmic function, it's going to be along the y-axis. Because remember, like I said, they are inverses of one another. Now, the way you draw it looks a little bit like this. This point, I'll go ahead and darken it in, and it does this. So as you can see, it has that shape of the exponential function. It's abiding by some new x and y values, arguably the inverses of each other, right? That's what it is. Now, if I wanted to go left, if I wanted to go right, let's go ahead and see how that would look. So say I did log of x plus 1, okay? Something as simple as that. Then that's going to take my dot that is at 0, 1, and it's now going to move it over one space, right? It's going to be right there. And so now, what does that mean for the asymptote? Well, it also moved over 1, okay? And it's now here. And so my new graph, or my new function, looks like this. Okay? Nothing too crazy, right? Now, if I wanted to go to the right, of course, then that's going to be the minus. And so I've got log of x minus 2. So it originally starts here, right? But now I'm going to go 1 and 2 and be right here. That, of course, moves the asymptote, right? And it moves it over 2, so it's going to be right here. And then when we go to draw, it'll look something like this. Okay? So as you can see, when you modify the horizontal translation, that directly impacts and affects where the asymptote is also moving. Okay? So just so you're aware. Now let's go ahead and talk about the vertical translations. Alrighty, so let's talk about going up and let's talk about going down. So if we were to talk about going up, we would have, and I'll use a different color, something like this, log of x, and then we could have, I don't know, plus 3 or plus 2. Let's do like a plus 2. Then that means we would take our point that starts here, right? It's now going to go up 2, so 1 and 2. So he's going to be right here. Now that does not impact our asymptote, okay? Our asymptote is actually still existing along this axis because all we shifted was up and down. Now that shift doesn't affect how the asymptote is going to move. And so we'd still have something like this. Just up now. Now, of course, down is the same exact process or treated the same way. You have your log of x, but instead of plus, you just now have minus, so like a minus 2. And so we start here at this particular point. We go down 1 and 2. And it does not affect the asymptote. The asymptote still stays at that y value, okay? So those are the translations, okay? Now the biggest thing to make note of is that one was inside of the parentheses and one was outside, okay? So that's how you make that distinction. But that's been the case forever, right? And as long as we've done transformations, okay? Now let's jump into the reflections. Alright, so let's go ahead and start off with a reflection across the x-axis. So what that's going to do is starting at that point, okay, and I'll change it back to red. right here, all this is going to do when you reflect it across the x-axis, notice how this right here, this part, and I'll go ahead and use my highlighter, this part is the part that goes straight up, that does not follow the axis, is above, okay, the x-axis. Well, now when you flip it, this section right here that's in blue is now going to flip downward, okay? And so it's now going to go this way, okay? It's going to flip down. Now, of course, the tail of it will still try to trace, oh, not pretty, there we go. We'll still try to trace the y-axis, because the asymptote, I mean, if you just flip the asymptote, I mean, that doesn't really do anything to it. The asymptote is still going to exist along this line, even if you flip it, right? It's just where now the part that's growing quickly is, and it's going to be now below. Now, where is the negative that causes that to happen? Well, remember, it's on the outside. So if you had a negative log x, okay, so that negative is in front of the log, causing this type of transformation. Now for the y-axis, of course, that's going to be having the negative on the inside, okay? And so let's look at this graphically now. So starting at that point, we now apply the negative to it. Well, that makes it flip to this side. So instead of it being 0, 1, it's now going to be 0, -1. Because think if you were to apply the negative to 0. Well, what's a -1 times 0? Well, that's still 0. Well, what's 1 times -1? Well, that's, that'll be -1, right? So that's why it flips to this side, okay? Now, the way it's going to operate for the rest of the graph is it's going to grow this way and then, of course, follow the y-axis for the asymptote, okay? So it's going to flip just like that, okay? So that right there is going to be the reflections, okay? So the idea is that instead of it going to the right when you reflect it across the y-axis, it now moves towards the left. And for the x-axis, instead of moving up and to the right, it's now going to move down and to the right, okay? And of course, we'll do full-on examples to kind of illustrate that more, and with practice, this will become a lot easier, okay? But let's go ahead and talk about the vertical stretches and compressions, and then, of course, the horizontal stretches and compressions, and then we'll be done. Alrighty, so for the vertical stretch, if you were doing that, that would be something like doing 5 log of x. Now, notice that for vertical, the scalars are always going to be on the outside, okay, not inside the parenthesis. And what that's going to look like graphically is it's still passing through this point, but what you're doing is it's now doing this. So the idea is that it's going to be stretching. It's going to be going more up first, okay, than it usually does. Now, in terms of for a vertical compression, okay, that's going to be your 1/5 maybe log of x. And so what that's going to do is that's going to compress it to go towards, you're going to be pushing it towards the x-axis, okay? And it looks something like that. Now let's talk about how horizontal stretches and horizontal compressions affect the logarithmic function. Alrighty, so when we look at these types, this first one, this would be considered a horizontal compression, right? And then this over here would be considered a horizontal stretch. Now, the reason for that is because, remember, it's the reciprocal. It's always the opposite. So a 2 would become a 1/2. So that's why we would say a horizontal compression of 1/2. And then a horizontal stretch would be the reciprocal of 1/2, which is 2. So this would be a horizontal stretch of 2. Now, like the exponential function, remember how I said that it's not necessarily like when you apply stretches and compressions, it appears to look like that you shifted it. Well, for exponentials, we had an issue where it appeared to shift it vertically. For logarithmic functions, it's going to look or appear to have shifted it horizontally, because remember, this is the inverse, right? So if you were to apply this right here, and let me do some math here for you to show you why the parent function is the way it is. If you were to do the log of 1, you get 0. Okay, so if you do the log of 1, you get 0. Okay, that's just how that works. Now, if you were to do the log of, I don't know, let's say 2x, well, how would you, or what number would x have to be for it to be a 1 again? Well, it would have to be a 0.5, right? It would have to be a 0.5 because 2 times a half, that would give you a 1. So this would then again be log of 1 is equal to 0. So that means if you were to do a horizontal compression of 1/2, not only would that compression take place, but also you would notice that the graph is going to shift or appear to shift over to the 0.5. It's going to look like it does that right there. And when you go ahead and compress it horizontally, it's going to do this. Boom, just like that. Now, looking at the, and I guess let me go ahead and draw it a little bit better. Let's see, it's going to swing out a little bit more, right? Because it's horizontally compressed, okay? It's going to swing out more. Now, the idea for the next one, log of 1/2 x, we have to figure out, what would x have to be in order for it to be a 1? Well, in my head, what I'm doing is I'm doing 1/2 x is equal to 1, right? I mean, that's why we learn algebra, to be able to create these types of formulas to figure out what we're needing x to be. Now, of course, x in this scenario has to be 2, because then I get log 1/2 times 2, that's 1. So that equals 0 again. So for this problem, it's going to start off at 2 right here. And it's still going to follow along that y-axis, but when it's compressed or stretched horizontally, it's going to hug the x-axis a little bit more. It's not going to swing out as wide. It's going to hug that x-axis. And so there you go. Now let's do some examples where we see everything in action, and let me know if you have any questions. Alrighty, so let's try this one. Let's do f of x is equal to negative log of 1/2 x minus 3 plus 2. So let's talk about the transformations before we apply them, and we're also going to be utilizing the boxes to kind of help us in figuring out where that key point is going to end up. Remember, the first box is always the parent function, and then the second box is multiplication and division, and then the third box is addition and subtraction, okay? So the negative in the front, this guy right over here, he is a reflection across the x-axis, right? And then looking at this over here, this plus 2, because everything on the outside, it goes to the y's, right? The plus 2, that's telling you to go up 2, right? And so if you were to implement these into the boxes, you would have, remember this is x, this is y. This would be times negative 1. And then over here, you'd be adding 2. Now, over here on the inside, the 1/2, we like to think of that as the reciprocal, right? So that is a horizontal stretch of 2 because it's also inside the parenthesis, right? So we say times 2. And then on top of that, the minus 3, that tells us we're going to go to the right, but we don't say minus 3 when in application, we actually add 3, right? So let's go ahead and apply these transformations. And since I have my blue, let's apply the transformations to all the x values. So what is 1 times 2? Well, that's 2. And then adding 3 to the 2, that gives me 5. Now let's go ahead and apply all the transformations for the y. 0 times negative 1 is still 0. Then add 2 to that, and so 0 plus 2 is 2. So our coordinate point that we care about the most is going to be at 5, 2. So let's go ahead and draw that. All right, here we go. Got my graph going. So that's going to be at 1, 2, 3, 4, 5, 1, 2. So that's where my point I'm interested in will sit. Now I want to kind of figure out where the asymptote is going to be. Now the asymptote is dependent upon where my translation was for my horizontal, right? So it was a -3, so that means it's going to be shifted to the right 3 units. So it's going to exist 1, 2, 3 right here. Okay, so that's where it's going to be. And that's going to help in drawing. Also, we have to be mindful that it was reflected across the x-axis, so that means it's going to be curving down and to the right. So we go down and to the right. And it should look something like that, and it will go ahead and stay near that horizontal asymptote, vertical asymptote. So there you go. There's one example. Let's do another one. All right, let's try this one on for size. So I've got 1, 0, and then this. Okay, so everything on the outside, remember, goes to the y's. So the 2 and the -1, and then everything on the inside goes with your x, right? So all this stuff in here. So the 2 on the outside, that is going to be your vertical stretch of 2, right? And then the -1, the -1 on the outside on the far right, that is telling you to go down 1. Now, let me go ahead and put those in. Remember, this is x, this is y. So we're going to be multiplying by 2 there and subtracting by 1. Now, everything on the inside, there's a negative there. And so we have a -1 scalar. So that's going to be a reflection across the x-axis. So times -1 there. And then a +3, that's going to be a -3. And that's telling us to go to the left, right? So let's go ahead and apply these transformations. So let's do the x since I have my blue out. 1 times -1 is -1. -1 minus 3, that's going to be a -4. Now let me get to my red. I'm going to do 0 times 2, that's still 0. Now 0 minus 1 is a -1. Now let's go ahead and apply it to the graph here. So that means I have, let me get some ticks going. I think that's enough. All right. And so let's do -4, -1. So 1, 2, 3, 4, and 1. So it's going to be over here. Now let me figure out where my vertical asymptote is going to be, right? It's affected by the horizontal translation. So that means it went to the left, -3. So that means it's going to be right here. Okay. Now with the reflection across the y-axis, we got to figure out, what is it going to do now? And it should do something like this, right? There we go. And boom, there you have it. All right, so if you have any questions or concerns or need more assistance on this, please reach out to me, let me know. You'll get to practice this and apply this some more on your assignments. But like always, let me know and I'll send you some more material to help you figure this stuff out. Thank you guys for tuning in, and I'll talk to you next time. Bye.